Hello, my name is Bobby Wilcox and I am the Director of Training for the Williams Automotive Group. Each and every one of our cars, trucks, and SUVs have amazing features that are specific only to them. But did you know that there are standard features that are included on every Toyota vehicle that you can talk about, regardless of model or trim level? These things are standard across Toyota's entire fleet. The buying motives of our customers typically fall under 4 categories: safety and technology, convenience, performance, and quality and dependability. Let's take a look at some of those features, starting with technology and convenience. One-piece body panels are single-piece panels that increase side impact resistance, body strength, and rigidity. They also help reduce body-related wind noise, squeaks, rattles, and improve surface finish appearance. Dash silencer and sandwich steel. The goal here is to reduce cabin noise for the passengers. Toyota implements the use of dash silencer material referred to as sandwich steel. Use of sound-deadening sandwich steel is, simply put, 2 layers of steel bound together with a composite sound-deadening material in the middle. This allows for the material to have sound-deadening qualities without compromising strength. This construction is used predominantly in the engine compartment and in the firewall in order to reduce noise transfer from the engine and the drivetrain into the passenger cabin. Ease of ingress and egress. Toyota has always done a great job with the hinging range of the doors in order to allow ease of entering and exiting the vehicle. All vehicles are now equipped with both tilt and telescoping steering wheels. Toyota Care is a program sponsored by Toyota that is automatically included with every new Toyota. Toyota Care covers normal factory scheduled service for 2 years, 25,000 miles, whichever comes first, and 24-hour roadside assistance for 2 years, unlimited miles. This program is good anywhere in the continental United States. Now let's talk about performance. Dual VVT-I, which is variable valve timing with intelligence. That's a technology that's built into all of our vehicles where the computer can actually alter the timing of the valves. What this does is gives you a more torque-oriented engine when you start from stop, and then as the vehicle speeds up, it will change the timing of the valves to give you a more horsepower-oriented engine. TDI, which is Toyota's direct ignition system, has replaced the conventional cap and rotor distributor systems as well as spark plug wires. We now have a single ignition coil for each cylinder. With this arrangement, the system is less susceptible to weather, moisture, or the deterioration of spark plug wires, thus ensuring accuracy and reliability of ignition timing and performance. In the absence of cap and rotor, the Toyota's direct ignition system receives timing signals from the intake and exhaust camshafts as well as the crankshaft position sensor. ECTI, which is electronically controlled transmission with intelligence. These Toyota transmissions, which currently range from 4 to 6 forward speeds, are electronically integrated with the engine computer. Shifts are timed and executed according to precise information based on vehicle's engine speed, throttle position, and even engine temperature and terrain. By sharing data, the engine and transmission can work together more efficiently, reliably, and smoothly. ECTI transmissions are self-adjusting with ongoing diagnostic programming that compensates for normal wear and tear. ACIS, which is our acoustic control induction system. This is standard only on our V-type engines, such as our V6s and V8s. This system changes the way the engine takes in air based on the engine's current situation. For example, in a start from stop, low RPM torque condition, the system will utilize the full length of the channels within the unit to inhale more deeply to help provide a more torque-oriented engine characteristic. This is like taking a deep breath before lifting a heavy object. Then as the engine's RPMs increase, veins within the system will open and allow the air to follow a shorter path to the intake valves in order to accommodate the higher RPM condition. Think of this as taking shorter, more frequent breaths of air while sprinting. At the end of the day, the engine is more able to inhale more efficiently throughout its entire RPM range. Let's talk about quality, dependability, and reliability. All of our Toyotas are built with dual door seals around each door. This ensures a reduction of noise within the passenger cabin, as well as an extra protective barrier from weather and the elements. Body parts, fit, and finish. Toyota prides itself on the precise factory manufacturing process that ensures consistency and precision by which Toyota vehicles are assembled. This can be demonstrated by using a business card and marking a seam or a gap and comparing it to the other seams and gaps throughout the vehicle. You should find that Toyotas have little or no deviations. Gold-plated electrical connectors. Resist oxidation and corrosion and conduct current better, thus greatly improving reliability and performance. This is used in vital circuits such as the fuel injection computer, oxygen sensor, and airbag sensors. Here's a fun fact about Toyota's reliability. 80% of Toyotas sold over the last 20 years are still on the road today. All of our Toyotas are constructed with corrosion-resistant steel. PVC Undercoating. A special PVC, polyvinyl chloride, plastic coating is sprayed on specific areas of the car after the clear coat has been applied. PVC helps to protect the body and helps to prevent underside corrosion. Wet sanding after machine sanding. Every Toyota is wet sanded by hand. This special care and 4 coats of paint are just 2 of the secrets responsible for the lustrous, long-lasting paint finish that characterizes Toyota vehicles. All right, now let's talk about safety. Let's start with crumple zones. Crumple zones are specially engineered areas of the front and rear of the vehicle to absorb crash energy. Tailored blanks are also used in portions of the frame and body. Tailored blanks are metal structures with varying thicknesses that are designed to collapse and compress under predetermined stress loads during a collision. By doing this, much of the energy from a collision is absorbed and diffused by the crumpling of the car structure, thus reducing the amount of collision energy transferred to the passenger compartment, hence the term crumple zone. Multi-stage airbags. An airbag's main function is to reduce the impact between occupants within the vehicle and the interior surfaces of the vehicle during a rapid deceleration event, such as a forward collision. Sensors and scales within the car will factor in the weight of an occupant, the seating position of the occupant, and the severity of the collision. Then within a fraction of a second, the system will factor in these measurements in order to alter or control the extent by which an airbag inflates. This will minimize injuries from the airbag itself. In other words, for lighter occupants, or a not so severe collision, the airbags will inflate only to the extent necessary based on these factors. In more severe collisions, the airbags will deploy to a fuller extent in order to best protect the occupants. This process is known as multi-stage airbag deployment. Based on this passenger information, coupled with the crash severity information, the airbag is deployed at either a high force level, a less forceful level, or not at all. Pretensioners and force limiters. A pretensioner automatically retracts the seatbelt and helps secure the occupant at the moment of severe forward deceleration. If the shoulder belt forces applied to the occupant reach a predetermined amount, then the force limiter allows for the webbing to extend to help reduce the pressure on an occupant's chest. This slows the deceleration of the occupant, thus reducing injury from the seatbelt. Energy-absorbing collapsing steering columns is designed to collapse in the event of a collision to avoid injuring the drivers. In years past, steering columns were rigid and were responsible for many injuries and deaths. Latch, which stands for Lower Anchor and Tether for Children, simply adds a layer of safety by anchoring and securing the child seats independent of the seatbelts. Side impact protection. You can't see them, but inside every door of our vehicles are high-strength steel beams. These beams offer protection to the occupants by increasing the structural strength of the vehicle. Side impact and side curtain airbags. In the event of a side impact, the side airbags will deploy to help protect the pelvis and upper torso, which become susceptible in side impacts. Additionally, Toyota also includes side curtain airbags, which are designed to protect the upper body, including the head. The side curtain airbags will deploy either by side impact or a vehicle rollover situation. TPMS system, which is otherwise known as Tire Pressure Monitoring System. Inside every wheel of a car and on the back side of the valve stem is a little pod that measures the air pressure within each tire. It then transmits this information to an onboard computer in the vehicle that will let you know when your tires become low on air. This helps ensure that you have a proper footprint on the road at all times, which ensures your safety. A STAR safety system is a bundle of 6 active technologies designed to help drivers adapt and maintain control of the vehicle during an emergency situation. Toyota was a pioneer in making these technologies standard on every vehicle, regardless of trim level. These technologies include anti-lock brakes, electronic brake force distribution, smart stop technology, vehicle stability control, traction control, and brake assist. Check out the next video that will highlight 3 of the very important braking systems within this bundle of technology.
ABS EBD BA. The anti-lock brake system, or ABS, helps prevent wheel lockup and delivers improved steering control during hard braking. ABS helps the tires maintain better grip on the pavement during difficult stops. And tires with better grip not only stop more effectively, they steer better too. ABS can help drivers maintain steering control while helping make the best use of braking power and tire traction. And that helps enhance safety and security. ABS EBD BA. The anti-lock brake system, or ABS, helps prevent wheel lockup and delivers improved steering control during hard braking. ABS helps the tires maintain better grip on the pavement during difficult stops. And tires with better grip not only stop more effectively, they steer better too. ABS can help drivers maintain steering control while helping make the best use of braking power and tire traction, and that helps enhance safety and security. By keeping all four wheels turning, even as the vehicle decelerates, the tires maintain better grip on the road. A skidding tire has less braking and cornering capability than a rolling tire. In fact, a skidding front tire can generate very little cornering force, so ABS helps improve a driver's ability to stop and steer at the same time. Electronic brake force distribution, or EBD, reduces brake pressure at lightly loaded wheels that are more prone to skid. EBD can help provide optimal brake proportioning to each individual wheel based on driving conditions such as the number of passengers, amount of cargo, deceleration rates, and when cornering. When a driver steps on the brake pedal during a straight-ahead stop, the vehicle's weight transfers forward to the front wheels. When a driver steps on the brake pedal while cornering, the vehicle's weight transfers to the outside wheels. In both cases, momentum shifts weight and reduces the braking grip on the specific set of wheels with less vehicle weight. ABS wheel speed sensors are designed to detect this wheel speed difference before it turns into a full-fledged skid and begin to reduce pressure to the less loaded wheels. With EBD, the brakes can be modulated more precisely to keep brake force at wheels with the most traction and maintain vehicle stability. Brake Assist, or BA, automatically applies increased braking power when it detects the driver is attempting to make an emergency stop. In sudden or emergency braking situations, some drivers, especially inexperienced ones, may panic and not apply sufficient pressure on the brake pedal. BA measures the speed and force with which the brake pedal is applied to determine whether the driver is attempting a sudden stop. If the system determines that is the case, BA uses high-pressure brake fluid stored in the ABS system to apply additional braking power to all four wheels. When the driver intentionally reduces brake pedal pressure, the system reduces the amount of brake assistance it provides. The additional pressure from BA helps to reduce stopping distances in emergency braking situations.
All right, now let's talk about Smart Stop technology. This is a technology that was built into our vehicles to avoid an unintended acceleration situation. If at any time that the accelerator is at least 33% depressed and the brake pedal is pressed for 1.5 seconds, the computer will return the engine to idle. Check out this next video that highlights this technology.
Smart Stop technology. Under certain conditions, the Smart Stop technology system automatically reduces engine power to help stop the car when the accelerator and the brake pedals are pressed simultaneously. It works automatically at speeds above 5 miles per hour when the accelerator is already open more than a third of the way, and the brakes are applied firmly at the same time. When engaged, engine output is reduced, helping to minimize the load on the brakes and bring the vehicle to a stop. Smart Stop technology incorporates sophisticated logic control, so the system will not engage when it's not needed. In certain driving conditions, inappropriate activation might be inconvenient and could be unsafe. For example, the system will not activate if the brake pedal is depressed before the accelerator pedal. This allows the driver to depress both pedals simultaneously when starting up a steep hill.
Vehicle stability control is a safety technology that will detect if a vehicle is not following its intended path or has lost control. Check out this next video that highlights vehicle stability control.
Vehicle Stability Control, VSC. If a driver enters a corner too fast, the front end will often push the vehicle away from its intended path, and the rear tires will have better traction. The vehicle will likely continue on a relatively straight path regardless of steering input. Vehicle Stability Control, or VSC, can momentarily reduce engine output and apply brakes at the front wheels and the inside rear wheel to help control the push-out tendency of the vehicle. If the rear tires slip, the front tires will have better traction, and the rear of the vehicle will likely swing, creating a spin-out situation. VSC can momentarily reduce engine output and apply the brake of the outside front wheel to help reduce the rear end swing. VSC can be beneficial when cornering on wet, snowy, or icy surfaces. VSC can also offer handling benefits during emergency maneuvers on dry pavement.
Traction control is a part of the Star safety system that utilizes the ABS wheel sensors to know if one of your wheels is slipping or gripping. What the computer will do will either reduce power or apply brakes to help transfer power from the wheel that is slipping to the wheel that is gripping. Check out this next video that will cover traction control.
Traction control, track. If a vehicle without traction control or track encounters a slippery surface, like in damp or snowy weather, its drive wheels can lose traction and begin to slip. Without traction control, a continuous stream of power will be sent to the slipping wheel, and the vehicle will typically remain at a standstill. A computer in the car monitors wheel speeds during acceleration. If one drive wheel is accelerating faster than the others, it indicates that wheel is losing traction during acceleration. When wheel slippage is detected, track uses ABS to pulse individual drive wheel brakes to help reduce slip. Additionally, the car's computer reduces engine output by modifying the throttle opening to slow drive wheels to match available traction. Power can also be transferred to the drive wheel that has the best traction, allowing you to continue safely on your way. Track can help limit and prevent slipping of the drive wheels when starting off, or when accelerating on a damp, icy, loose, or uneven surface. The power reduction and braking technique used by track can help distribute the engine's power evenly to the drive wheels. When power is distributed evenly, there is less chance of one or both drive wheels losing grip and spinning.
If you have any questions about these technologies or systems and need help on how to deliver the information to your customer, grab a manager or you can contact me at any time.
Wesley Chapel Toyota.